With the increased use of fertilizers and industrial chemicals, it is becoming very common for runoff to carry these nutrients into our waterways. This causes harmful algal blooms that threaten the health of people and wildlife. My name is Paul Schember, and I teach 8th grade science at Norwood Middle School. I developed a project called Save the Soil to improve students' understanding of earth science concepts in an interactive way. To hook my students' interest, I first used a gallery walk featuring images of fertilizer use, erosion, and algal blooms. Students responded to questions that encouraged them to see how these topics were related. I also set up a relay race to further emphasize the concept of erosion. Students competed in relay fashion to destroy a simple sandcastle with spray bottles. Next, we worked on developing the big idea for this project. Think, Pair, Share was used to generate potential project ideas. After reading students' ideas, I presented them with the challenge. Discover ways to minimize erosion on farmland and apply these ideas to a model farm. A simulated rainstorm would try to erode their farm's soil and fertilizer materials. Students' questions about this new challenge were developed into a list that would help to guide this challenge. The engineering design process was introduced as a method for logically breaking the challenge into manageable steps that would lead to a useful solution. My students completed a stream lab to gain experience with erosion principles. The effects of slope, obstacles, and other variables were explored. Students also took notes and completed a research worksheet for homework to gain erosion control ideas. They found an impressive variety of erosion control methods, and I sourced materials that would work as suitable models for these methods. Groups then discussed the various erosion control methods. For added realism, each group could only apply 2 methods at a time on their model farm. Teams chose their materials and carefully installed them on the farm. Options included silt fences, no-till soil, terraces, and many others. The completed farms were placed on the angled platform and 1,200 milliliters of water were added to the rain box above the farm. The runoff was collected and strained, and the lost solids were measured and recorded as data. Each group had 2 more chances to refine their farm designs by choosing new combinations of erosion control methods and testing them on the Rainmaker. After testing 3 different iterations of their farm designs, students analyzed their data and made conclusions about best practices. Posters were developed as visual aids, and each group presented its findings to the class. Presentation questions on a poster guided the students as they talked. Student learning about the topics of weathering and erosion definitely increased as a result of this project. Students were able to see how soil loss and algal blooms were related, and this real-world application helped them to see that learning about erosion had a practical purpose. Throughout this project, careers in the areas of agriculture, engineering, and environmental science were discussed. This project also showed the impact that erosion has on the drinking water that comes from the watershed, as well as recreational water activities like fishing and swimming. My students were really motivated to participate and succeed, and they improved in the areas of problem solving and teamwork skills. They also got to experience weathering and erosion, and many wanted more time and information to research erosion control methods. My students also enjoyed the chances for creativity and greater autonomy offered by this challenge. As a teacher, I found managing all of the materials in one classroom to be a challenge, but it paid off in the results. I would like to thank the University of Cincinnati and the National Science Foundation for providing the opportunities to make this project possible.